This video looks at the hard questions on improper integrals. So we've got three examples to consider. First one has infinity on both of the integration limits. And the second examples have functions that are undefined for part of the graph. So let's have a look at example 2 on page 19. Now, in this case, I've completed the solutions in advance and we're going to talk through them. So I am being asked to integrate this function and then to evaluate it between minus infinity and plus infinity. So for part A, I am going to consider the best way to evaluate x e to the minus x squared. Now I can see by looking at it that if I were to differentiate x squared, I would get a 2x. So it looks like the function is being multiplied by its differential. If I'm not sure, it's best to go to substitution. So if we let u equal minus x squared, do my pre-working, rearrange so that I get dx, I'm then in a position to substitute and turn it into an integration involving u's. So the exponential function becomes e to the u. The x is going to cancel when I replace the dx, and you can see the x is cancelling there. So I'm left with minus half e to the u du. I integrate, and then I put the minus x squared back in, and there I have my integration result. So that's part A, the evaluation of the integral. Now what I'm going to do is to consider the fact that it's improper and use my technique for working with limits to evaluate the integral and decide whether it's convergent or divergent. So my technique is to split it into two integrals. So I have to have one going from minus infinity up to 0 and the second one from 0 up to infinity. Why have I split the limit at 0? I could split it at any value in actual fact, but 0 is going to make my subsequent working easier than if I chose a different value. So that's what we do. Now, considering the first integral here, I've taken my result from part A, and I'm going to sub in my 0 and t. You'll see that I've replaced the minus infinity with a t, and we are going to evaluate the limit as t tends to minus infinity. So I sub in, and then I consider what happens when t tends to minus infinity. As you'll see, this term here tends to 0. That means that my overall result is equal to minus a half. I then evaluate the second integral in a similar way. This time I'm working between 0 and plus infinity, and I've replaced the plus infinity with a b, and I'm going to let b tend to infinity when I evaluate the limit. It's good practice to use different letters, so we've got t here and a b here, just to keep things clear. So I follow through the same process, and this time I get a value of a half. That means that my original improper integral, which I called I here, can then be evaluated as the minus a half from the first integral and the plus a half from the second integral, which when combined give us an overall value for the integration of 0. So that's question 2. Let's now have a look at questions 3 and 4. Question 3 gives us an example of an integration where the function itself is undefined at a particular value. In this case, our function is undefined at a half. So we split the integral into 2 and we put a half on both of the integrations. So we go from 0 to a half and a half to 4, so that we've covered the whole integral, but with the split at a half so that we can evaluate the limit at that value. Now, I'm going to consider these ones separately again, because what we're going to find in this case is that one of them diverges. So considering this one here, I undertake my integration and I am evaluating it as a limit as t tends to a half. So you can see that I've replaced the half with t. I've done the integration, I've subbed in. I now consider the limit by letting t tend to a half. This term here tends to infinity. Therefore, I do not have a finite answer. That means the integral does not exist and it is divergent. As I have achieved this result for the first integral, I do not need to evaluate the second one because the overall improper integral is divergent. Now, this layout here shows the integration being done within the evaluation of the limit. And as you can see, you end up writing the limit of t tending to a half on every single line. So in terms of good practice, it is a good idea to do the integration initially and then do the limit work. That's what we're going to do on the next one. So let's have a look at question 4. So question 4, I'm being asked to integrate x log x between -1 and e. So we'll do the integration first. You will recall that it requires integration by parts, and because it's a log, we arrange for the u to be the natural log of x. I evaluate that, the working for which is here. I'm then going to come on and consider the improper integral and the limits. So this time I'm going to keep all the working on one line. So I've got the integral split at the value 0 because it is the 0 that causes this function to be undefined. So I now have to evaluate 2 limits. First one here, I'm using the letter a, so that's between -1 and a, and I'm going to let a tend to 0. And the second one, I'm using the letter b, so that's from b up to e, and I'm using b tending to 0. I must have 2 different letters in this situation so that I'm evaluating the limits clearly. So there is the -1 and the a being subbed in, and there is the b and the e being subbed in. I then consider what happens when a tends to 0. This function tends to 0, and what happens to b when b tends to 0. This tends to 0. That means that from both of those integrals, I am left with these terms, which simplify to an overall value for the improper integral of 1/4 plus 1/4 e squared. So those 3 examples give you the case when we have 2 infinity signs and 2 examples where you have functions that are not defined between the limits of integration. The first one, we only had to evaluate one of the integrals. The second one, we did have to do both of them, and you've seen various ways of laying out the work.